Welcome to another broadcast of Truth Be Told, where we believe in experience becomes truth. I'm your host, Tony Sweet, and joining me now in studio, you have your other host, Captain Ron. Well, today we're going to space, the final frontier. Yes, we're going to talk about planets, solar systems, super Earths, and much, much more. As you know, NASA recently found 7 Earth-sized planets that could host water and life discovered orbiting another star. Well, that leads us to our guest today. We have Michael Summers, who wrote a book. It's called Exoplanets, Diamond Worlds, Super Earths, Pulsar Planets, and the Search for Life Beyond Our Solar System. Since its 2009 launch, the Kepler satellite has discovered more than 2,000 exoplanets and planets outside our solar system. Astronomer Michael Summers and physicist James Trefil explore these remarkable recent discoveries. Planets revolving around pulsars, planets made of diamond, planets that are mostly water, and numerous rogue planets wandering through the emptiness of space. It's going to be a fascinating conversation today because with the background of planetary scientist and professor of physics and astronomy at George Mason University, and our guest Michael Summers has also served on the mission teams of several NASA space probes in the role of science planning and interpretation of spacecraft observation. So it's going to be a great show, guys. So let's go ahead and get this conversation started. So please welcome to Truth Be Told, Michael Summers. Welcome, Mike. This is great. We are so excited. We're so excited. Well, in the last, was it 3 weeks, month, that there was new planets discovered. Right. And your book came out right on time.
Designed it that way.
Did you plan it? Yeah. Is that, did you plan it? Planet?
Planet. Did you plan it?
Wow.
Well, one thing that Captain Ron wanted to ask you.
Oh yeah, I looked through the book, and it's excellent. It's just not as funny as I expected it to be.
You have to work on the humor a little bit.
That's right.
That's right. Little like hand drawings. So tell us your thoughts on the new planets discovered.
Well, the recent planets that were announced about 2 weeks ago was in the TRAPPIST-1 system, and there were 7 planets discovered, all of them about the same size as the Earth. And 3 of them inside what we call the green zone, or the habitable zone around that star. And that's what's exciting, because planets at a certain distance from the star can host liquid water. And this is the image that you're seeing now is an artist's rendition of what these planets might look like. And so having 7 of them that are Earth size and 3 of them in the green zone, and the other 4 might even have water as well, but maybe it's frozen or in a vapor phase. It's pretty exciting, because if you think about it, these planets have water, they have energy from their star, and they have rocks and minerals, all the resources, all the requirements for life as we know it, as we learn in elementary school, what you need for life. These planets have it. Now, that doesn't mean that these planets have life. We don't know that. And in fact, we only know just a little bit about these planets so far, but they're incredibly exciting because they're close enough that we will be able to learn more about them in the future with new telescopes that are coming online. And within a few years, we're going to be able to know what their atmospheric composition is, and we'll be able to look for signatures of life on these planets.
Okay, here's my thought.
Sure.
Okay, they're a long ways away.
Right.
Even with telescopes.
Yeah, so when he says nearby, that's relatively speaking.
Yeah, it's like, it's 700 light years? How many light years away?
Well, these are about 40 light years away. And so that is pretty far away. It's about 10 times as far away as the nearest star.
Well, because I remember looking it up, and each light year is how many miles?
That's a good question.
Oh, I didn't mean to stump you there. Oh, I stumped the scientist.
Trillions. It's trillions.
I think in parsecs and in light years. I mean, once you get out to numbers that are in the quadrillions, it kind of loses its meaning. It's much easier to talk about light years. The way I like to explain it is that light takes about a second to get from the moon to the Earth, about 8 minutes to get from the sun to the Earth. When we sent signals from the New Horizons spacecraft to Earth, it took 4 hours, and the nearest star is 4 light years away.
Wow.
That gives you a sense of the distances we're talking about. So 40 light years is indeed a long way away. But on the other hand, we have some pretty powerful telescopes now and some instrumentation that's extremely sensitive so that we can measure their mass.
Well, that's
their
what I was going to
size,
ask.
get their density. We can tell you what their orbital period is around the star. We can do a lot of things. Now, some of it's inferred, some of it's not directly measured, but we use physics and chemistry. The same physics laws and chemistry laws that work here work everywhere in the universe. So we can use that to determine a lot about these objects. But of course, it would be better to go there.
Well, I just looked it up, and it says is 1 light year is about 5.88 trillion miles.
Yeah.
So times 40.
You want to carry around in your head. It's much easier to say 1 light year, isn't it?
Yeah, that's probably why they do that.
Yeah.
So that's what I was going to ask is how would you even determine that it has the possibility of life when you're looking at it through? I mean, because I grew up and it's this small, like a telescope about this this long. So these must be so powerful of telescopes that you wouldn't think it's like, oh, look, there's Bob driving to the grocery store. Yeah. So it's like, that's what I was trying to figure out. How would you even tell if they even could have life on it?
Right. Well, first of all, it's not easy. You do have to use the most advanced and sensitive instrumentation we have on telescopes and the biggest telescopes that we have. It's right on the frontier of science of what we can do is to look for signatures of life on other planets.
Right.
However, sometimes those signatures are very obvious. For instance, think about the air you're breathing. It's oxygen and nitrogen, and that comes from life on Earth. It comes from photosynthesis and nitrogen-fixing bacteria, denitrifying bacteria. And so nitrogen and oxygen represent what we call biomarkers of life on Earth. Now, suppose we look in the atmosphere of a nearby planet and we see oxygen and nitrogen and CO2 and methane and all the things that come out that are produced by life. That's an indication that there may be life there. It's not proof, but it is a set of what we call biomarkers or signatures or markers of life. And that's what we look for. When we look at planets that are far away, we study the light. And in the light, you have information about the content of the atmosphere.
Well,
does that make sense?
No, it does. It does make sense. Even if it doesn't, I would say it does.
It's hard to believe, but it's kidding. It's amazing.
But okay, so I know that we're finding new discoveries of planets all the time, and even stars. Without a telescope, how do we do that? Is it possible to do without a telescope?
Not really.
He looked at me like, really?
In Kentucky, where there are very few city lights, and you could see maybe 2,000 stars in the sky
right.
on a really, really dark night. But our galaxy has around 400 billion stars. So you can't see those without a telescope of some sort. In fact, most of them are on the other side of the galaxy, and we couldn't see them anyhow because we'd have to see through other stars, and it just wouldn't work out. But that's a lot of stars, and they're far away. So you have to use big telescopes. They're like big eyes. Think of them as, your iris gets bigger and lets in more light. If it got bigger and bigger and bigger up to it's 10 meters across, then you'd have a giant telescope, a giant eye that could see really dim things far away in the galaxy. And that's essentially what we do with telescopes. So we've got big eyes that look very far away. And so the planets are dim, there's no question. They shine by reflected light from their star.
Right.
But yet we can still detect that light, the small amount of light, we can detect it, and we study it. And the way we study it is that we use effectively what is a prism. I think maybe in elementary school, you shine a light through a prism and you get a rainbow, or you see a rainbow after a rainstorm. And that color distribution has information about the atoms and molecules in the air that scatter the light. And that information is what we want. That's what we covet, because that information tells us all the things we want to know about the planets.
It's insane to me that you can discern that just from the light being reflected.
It's just incredible to even think about the numbers of planets that we're finding. I mean, when I was a kid, there were 9 planets, okay?
Right. Period. Right.
Right.
This has changed so dramatically in the last 20 years, right?
You have to check every day now to see how many planets we now have discovered. I checked last night, and there's 3,593 planets that have been discovered outside of our solar system. and that have been confirmed by a second set of telescopic observations. So they're confirmed observations. And if you average out the discovery rate, we're discovering whole new worlds, whole new planets at a rate of about 2 per day. Okay.
Wow.
And just think about the civilization over the past 1,000 years, how long it took Europeans to colonize North America, and how big a deal it was. We're finding whole new planets at a rate of about 2 per day. And that rate is going up. In 10 years, we will probably have determined the existence of over 100,000 planets
Jeez.
outside of our solar system.
Now, how many of those planets that could sustain life?
Yeah, that's the question. We can only talk about the ones that we've seen so far. And of those, around 3,600, about 200 of them are Earth-sized, Earth-like. And about 45 of those are in the green zone, where the temperature is just right to have liquid water and oceans and a hydrological system like we have on the Earth, rainstorms and rivers and that kind of stuff. About 45 of those are of that kind of place where you could have life as we know it. Again, we don't. There could be life as we don't know it. That's
right.
Always a big caveat that we have to be humble enough to admit. There could be things out there that we just don't understand at all. And probably are things out there we don't understand at all.
And probably don't want to understand.
There's always that possibility too.
Hey, Michael, isn't it true though? Okay, so looking at the rate that these are being discovered, isn't it true that not that long ago we didn't think there were any other planets?
Well, that's always been a big question. When I was in graduate school in the mid-'80s, we knew of the 9 planets, but we had endless debates on whether or not there should be planets around other stars. And I think the consensus was that the planets are probably rare, which is kind of strange now, because now there are more planets than we can possibly discover.
That's what I was getting at, that it's changed from one extreme to the other, that they thought, well, maybe, but it'd be extremely rare. Now we feel like there's a plethora of them.
Yeah, and we thought our solar system with 9 planets was unusual. Now we know it's pretty typical. When you go outside and you look in the sky and you see a star, on average, that star is going to have about 10 planets around it. And on average, it's going to have 1 or 2 habitable planets for life like we understand it, carbon-based life. And so that's kind of astonishing. Just go out and look at the sky sometime and think about 10 planets around each one of those stars. And the numbers, I mentioned 400 billion stars in our galaxy. That number of stars is larger than the number of people that have ever lived on Earth. And if you take that and multiply that times 10, you're talking about more planets than the number of heartbeats of all the people that have ever lived.
Jeez.
Okay?
That's
in the observable
nuts.
universe. Okay. So, we haven't discovered those yet. That's just what we call an extrapolation. But that's what we're seeing. That's what the evidence is showing. That's what the indications are.
And I find it fascinating that that's the indications now. But if you talk to a astrology professor 25, 35 years ago, they would have not said that at all. They would have said the opposite is true. There's probably very, very few. And now our thinking has changed completely.
Completely, absolutely. Right now, we're going through a golden age of discovery in planetary sciences. I mean, there's no time in Earth history have we ever been seeing this kind of an explosion in knowledge about the universe beyond Earth. And it's just overwhelming. When we put this book together, when we were trying to outline what we wanted to talk about, there was just so much. How do you cram it all into just a few chapters? There are more planets now known than the number of planetary scientists in the world. I'm serious.
That's great.
I kid around. I say, well, that's job security.
Right.
But on the other hand, there's not enough people to even study them all. What are we going to do? We're going to have to develop computers with artificial intelligence to study them. But and it's much richer, much grander, much more bizarre, much more complex than anything we thought 25 years ago. I just can't imagine what it's going to be like 25 years from now.
Well, that's what I was.
I'm having a hard time just understanding what it is that we're seeing now.
Well, that's what I was. I'm getting a little feedback.
Well, Tony, what are you doing?
Did Did you increase your volume real quick on your end?
I haven't done anything.
Oh, okay, because I'm getting a feedback. Hold on one second. So what I'll say is, when 25 years ago the telescopes were still great, but what has been done with the telescopes to make them so great now? I mean, compared to 25 years ago.
That's a very good question. The telescopes have gotten bigger and better. We now have a telescope in space called the Kepler Space Telescope, which is dedicated just to looking for planets around other stars. But we also have new instrumentation to put on these telescopes to measure very small changes in the star due to a planet going around it. Like if a planet moves in front of a star, the light from the star dims a little bit. And you can measure that now with the instruments that we put on telescopes. It's called a transit technique. And from that little bit of dimming of starlight, we can tell you how big the star is. We can tell you its distance from the star. We can tell you the orbit. We can start telling you information about its atmospheric composition. We can tell you about its temperature. And so you build on what you know from these observations. And that's one technique. There's another technique which actually preceded the transit technique, but it's called the radial velocity technique. And planets, as they go around the star, they gravitationally tug on the star and cause the star to move a little bit. And now we can detect that motion with other kinds of instruments. And that's called the radial velocity technique. And these two techniques, which we talk about in the book, have allowed us to discover most of these 3,600 stars. That's the technique those are the two techniques that have worked the best. And the techniques are just getting better and more sensitive. Every year, it seems like there's a new breakthrough in the sensitivity of the instrumentation. And if you want to know what's next, and this is
that's what I was going to ask.
The community is really thinking about. There are two things that are on the horizon that all the scientists are thinking about. One is the detection of these signatures of life, what we call biomarkers on other planets, because the discovery of life elsewhere will be one of the biggest discoveries in all of history.
Of course.
That's one thing. The other thing that's pushing our development instrumentation is pictures. We want to take pictures of these planets that orbit other stars. And within 10 years, maybe 15 years, depending on how budgets for science settle out, we're going to be able to take pictures of planets that are going around stars 4 light years away. I mean, think about that. We can't even see the planets right now without extremely sensitive instrumentation, but we're going to be able to take pictures of these planets and see if they have clouds and polar caps or oceans or storms or continents, and we'll be able to take and watch those planets change with time.
And they'll come right to our iPhone, right?
Pardon?
It'll probably come right to our iPhone soon. We'll be able to watch it, real time almost.
Absolutely. Actually, that's what's going to happen.
Amazing.
I mean, right now you can download much of the Kepler data right to your laptop and start working with it.
Wow.
In fact, if you'd like to do that, I'll show you how. We could use some help.
Oh, I would love that. Well, I'm going to ask this. So what is it? Why should we care? I mean, because there's a lot of people
Tony.
like that. Well, here's the thing is, people don't seem to care about, it's the environment, whatever. We're not. Why should we care what's in other solar systems? How's it going to help us in this solar system?
That's a really good question, and I get that asked quite a lot because it's difficult. It takes resources, it takes time, it takes an investment to explore space, to build the telescopes. But think about the way we're communicating right now. We're using satellites in orbit, communication satellites. We use weather satellites to monitor weather on the surface of the Earth. We couldn't do most of the things we do right now with computers if we didn't have space technology or technology that was developed for space exploration. Now, when you talk about what we're learning from other planets that helps us on Earth, you have to look at the bigger picture. You have to look at planets as a system, as a whole. Think about our Earth as an entity, as something that formed 4 billion years ago, 4.5 billion years ago, and has been changing and is going to keep changing in the future. And humans may even affect that change. How do we know what's normal and what humans are doing to it? Well, you can answer that question by looking at other planets and seeing how they've evolved, seeing how they've formed. The analogy I use sometimes with my students is, say, suppose that you were a physician and in all your career, you could only study one patient. How would you know what was normal for that patient?
True.
How would you know if the patient was healthy or about to die? How would you know if that patient was even young or old if you just looked at the patient and had no history to it? By looking at all these other planets, we're able to understand the Earth and see what is natural, what humans are doing to affect it. And there are very practical things about studying other planets too. One of the big issues in climate change right now is that storms appear to be getting stronger and more destructive. Hurricanes appear to be getting bigger,
right,
and more frequent. And the question is, how big can storms get and how destructive can they get? Well, we can just go next door to Jupiter and we see hurricanes that are bigger than the Earth. So right there, we have evidence. If you could find a picture of Jupiter, it'd be great, because there's a red spot on Jupiter that is a hurricane that's twice as big as the Earth. Think about that, a hurricane twice as big as the Earth. So we have visual proof that storms can get vastly bigger than anything that we see in the atmosphere now. See that red spot down in the lower right?
Right.
Yeah, that's it.
That is bigger than the Earth. That is a hurricane. If you put a big hurricane from the Earth on that red spot, it would just be a dot. So we know that hurricanes can get much, much bigger than anything we've ever seen in human history. So there's apparently no limit to how big they can get. Now, so what other factors control how big a storm gets? That's where you have to get into the science of weather modeling and climate modeling. And how do you test those models? You compare them with predictions that you make for the Earth and predictions you make on other planets. And by that comparative study, you're able to improve all your models of weather and climate on the Earth. Now, I'm oversimplifying in many, many ways here.
Right.
But the idea is that you can learn about the Earth, about how the Earth evolves, how it behaves to forcing from human activities of the sun by looking at other planets. But now Jupiter is only one planet. Now, if we have 1,000 other planets to to study, we can get a better insight into what's average, what's normal for a planet, and what's abnormal for a planet. What is a pathology as opposed to something that's healthy? I don't want to put it.
No, that makes sense. Listen, I love this analogy of the patient thing. I think that makes perfect sense, because now the other planets give us a frame of reference for where our planet is. Like you said,
Absolutely.
young or old. Without that frame of reference, you have nowhere to know, to base it on. So that's fascinating. Now, out of these 3,600 that we've discovered that are active planets, it's amazing the information you guys are able to cull from that, like what kind of atmosphere, what kind of elements are on those planets. Do you have any examples of like any of the most unique ones that seem, we're always looking for the ones that are most Earth-like, in the Goldilocks zone or the green zone, as you called it. We want that. What are some of the most bizarre ones that we found that maybe just opened a brand new field of thinking for us?
Yeah, that is actually one of my favorite questions, because most of the planets we're finding are bizarre.
Really?
Yeah, I mean, I mentioned that a couple hundred of them are Earth-like, but the rest of them are just beyond imagination.
Wow.
I mean, think about a planet that is 5 times bigger than the Earth, but all water.
Holy
I'm
crap.
not talking about covered with water. I'm talking about water from the outer edge to the core.
What?
Water.
How's that even possible?
Yeah, how is that
to
possible?
keep floating
Well, I
there?
don't know how it's possible. I'm just telling you what
That's what you're here for.
How would you ask him that question?
Well, I sure as hell don't know, and I know this guy doesn't know.
I was going to answer, but since you got it, no.
it's better. There's planets made all of metal. I mean, how do you
Metal?
do that?
Wow.
Metal, nickel, and iron. There are planets that we think are completely molten. Take an Earth and just heat it up until it just melts completely. There are 2 planets that we think are made mostly of carbon. And I'll ask you a question. What is carbon at high pressure?
Diamonds.
Diamond. So if most of the
sitting on one right now,
planet is
I think.
carbon, and you've got a planet that compresses that to high pressure, then most of that planet is going to be crystalline diamond.
Wow.
Think about a mantle of crystalline diamond that's 10,000 miles thick. And in the core of that planet, the pressure is so high that the diamond flows as a liquid.
Holy crap.
Don't mention this to my wife, please, no matter what. Just I'm going to skip this part.
The market, right? So
Right.
it wouldn't really help things if we had all these diamonds. But it doesn't really end there. You almost anything you imagine, you can find. Think about planets that go around 2 stars, or planets that go around 3 stars, or planets in 4-star systems. We found 2 examples of planets that are in systems that have 4 stars. It almost never gets night.
That's unbelievable.
The science fiction story Isaac Asimov wrote a long time ago called Nightfall, a civilization that was in a system where there were multiple stars, so it never became night except once every 10,000 years, and everybody freaked out. But now we see examples of that in reality. And we can, you could go on and on, just about anything you could imagine.
Well, let me ask you this then, since you want me to imagine. All of them, as far as I know, go in a circular or elliptical pattern. Has anything ever got caught in another orbit where it would be almost a figure 8, where it goes around this and then goes around the other body and then back? Does it ever change direction like that?
Exactly. It has to obey the laws of physics. It has to obey the force of gravity from the central star. But if you have 2 stars there, it can do some really bizarre things.
Wow.
And if you have 3 stars, it could have an orbit that never repeats. I mean,
wow.
Talk about a ride on that one.
Wow.
You might end up being able to predict the seasons, but you can't expect them to ever repeat. And then what happens if you have 4 stars? It just gets more and more complex as you think about this. But
now I see why you enjoy doing this.
Yeah, this is fascinating to me. I love it.
You want me to go on? I mean, think about
Yes, please.
a metal planet that is extremely cold. Then it's what we call superconducting. If you have an electrical current flowing through it, it'll just keep flowing forever. You might have life that forms on such a planet that would be formed with nothing but electrical and magnetic fields that keep growing and interacting. You could have a whole planet that's a thinking machine. Think about planets, but think about a whole planet that's moving through space at 1,000 miles per second. Okay? Think about anything moving at 1,000 miles per second is incredible speeds, but yet we find planets that are moving at that speed that are being shot out of the center of our galaxy.
I believe you. I just don't, it doesn't seem possible that exists, A, or B, that we're able to detect that. Isn't that amazing? It feels beyond our reach.
Yeah. But again, as I say, it just keeps getting stranger. With all of these things we've been talking about, think about what's happening between the stars. We're just now being able to detect planets that are floating around between the stars. And it looks like there are far more of those than there are planets that are tethered to stars. In other words, these rogue planets or stealth planets may outnumber the bound planets by a factor of 10 or 100 or 1,000. That means that between our solar system and the nearest star, there could be 10 planets that are these stealth or dark planets. And that would completely change the way we think about interstellar travel. We wouldn't have to go the whole distance in one jump. We could just go to the next planet, refuel, hang around for a while, then go to the next planet, refuel, and go on. It completely changes the way we think about our place in the galaxy.
Speaking of refueling, we're going to have to take a quick break here.
Oh, sure.
And let everyone's brain just kind of digest what they just heard, because it's all absolutely fascinating to me, and I mean that genuinely. We'll be back in 1 minute. It's Truth Be Told with Captain Ron and Tony Sweet.
Don't forget me.
I won't. And we'll be right back with Michael. This is just fantastic. We'll talk to you in 1 minute, Michael.
Sure.
You suffer from anxiety, from depression, maybe even chronic pain? Well, listen up. Truth Be Told is going to tell you about a breakthrough program built on over 100 years of therapies used in America's returning veterans to help you successfully overcome PTSD, anxiety attacks, pain, and depression. The secret proven in study after study. Music therapy. The effects of music are nothing short of amazing. From strokes to PTSD, music has been shown to improve the quality of life. Now, one of the latest music therapy programs being used in America's veteran hospitals can be yours to experience for free at home and to help your own anxiety attacks, pain, and depression. Or just relax after a hard day. It's called Whole Tones. It takes music therapy to a new level. This revolutionary program makes use of specifically designed frequencies that have been shown to stimulate your body's natural healing power down to a cellular level. If it works for battle-scarred vets, can it work for you? Well, experience it for yourself for free at sweetwholetones.com. Like Tony Sweet, that's SWEET. Go to sweetwholetones.com. Now enjoy the show. All right, we're back. This is Truth Be Told. I'm Tony Sweet. We have Captain Ron here. We're speaking with a planetary scientist, and he's a little bit smarter than I think we are, though.
Ish,
yeah. And we have Michael Summers with us, and he has a book that's, just going to be outstanding for anybody that picks it up. It's called The Exoplanets, Diamond World, Super Earth, Pulsar Planets, and the new search for life beyond our solar system. Mike, this is so fascinating, and we were just talking about how when we were in school, so we don't know what's being taught in school now because it's been a while since we've been in school. So is this at all taught in our school system?
It is, but it's behind the frontier of discovery. It's, for some reason, it's slow getting into the school system. I was talking to a middle school student this afternoon, and in their science class, they are still struggling with whether there are 8 or 9 planets in our solar system.
Wow.
And so they haven't caught up. Our educational system doesn't get this information into the school system to excite the students, to inspire them as rapidly as it should.
What's the answer? Is Pluto a planet? Yes or no? Do you have the answer, Tony?
Yeah. Because I heard him say it.
Of course.
It is, okay.
But the answer, okay, is that I think scientists need to do a better job of communicating the discoveries to the public. In a way, I think that scientists have kind of failed the public by not sharing this thrill of discovery, this excitement that we have when we find out that the universe is not only bigger and stranger than we imagine, it's bigger and stranger than it's even possible to imagine. And that everywhere we look, we're faced with new discoveries and new things that make the universe more complex than we thought. It's not simpler than we thought. It's like we're surprised everywhere we look. It doesn't matter how much we study about the universe. When we get a new telescope, when we send a new spacecraft to another planet, we're always incredibly surprised by what we find. And I think that our educational system needs to find a way, or scientists need to find a way of getting these discoveries into the educational system as they happen. And I don't have a good answer for that. What I try to do is I go to lots of schools and give talks. I give public talks by 2 or 3 a week. And I like doing it. It's a lot of work. But if 10% of the scientists in our country did that, we could fix that problem.
Right.
We could inspire the next generation of astronauts. We could inspire the next generation of Nobel Prize winners to really solve the problem of cancer or energy generation or the climate change problem. We could really inspire people to do that. I think that scientists have sort of hold themselves up too much and not shared this thrill as much as they should. Most scientists are introverted. I'm an introvert. It's hard to get out and do this, but yet we got to. I think it's a responsibility we have to do it.
Well, I think when the space program started, what was probably 50s, 60s. When did the space program actually start?
Well, NASA was formed in the early 60s, and most people think about the beginning of the space race as President Kennedy's announcement: we're going to go to the moon, send men to the moon, and return them safely to Earth before the end of this decade of the 60s, which we did. And there were some challenges, but we accomplished it. And during that time, many of the scientists that exist today were inspired. I was inspired.
That's what I'm saying. Yeah.
Well, Tony says we haven't gone to the moon. He doesn't believe it. So
I don't even think there is a moon, right? No,
we can talk about that later.
Oh, okay.
but those kind of things inspire people. What we're doing now with these discoveries are just as significant. In fact, some ways, this is far more significant for understanding our place in the universe than going to the moon. Going to the moon was sort of a competition with the Russians, and then we did it, and then it was over. But now we're making discoveries that are going to continue for as far in the future as we can imagine.
Wow!
And there's no way of seeing how this could end. I mean, I know it's corny, but I grew up with Star Trek, the final frontier. And the irony is that there is no limit to the frontier in space. It just keeps going on and on. And so what does that say about what we're going to discover? I mean, I can't imagine what we're going to discover in the next 20 or 30 years. I'm having a hard time just keeping up with it today.
What do planetary scientists think of like the multiverse and things like that? Or you guys stay strictly in this universe, I guess?
I think we've got enough to do as it is with 36 planets. So there's not a lot of time to think about other universes just yet. Now, maybe when we catalog all the planets in our galaxy, we'll start thinking about those things. I don't have a particular view on it, except that it's an interesting idea, but there's no physical evidence that other universes do exist. It's a speculation that may or may not be true. You can't say it's untrue, but you can't say it's true until you have evidence for it. And I don't see any evidence for it.
Okay. Truth be told, we've had many ufologists on. So this question is going to come up sometime. Could there be life on other planets? I mean, there has to be. I mean, it's almost
that we know. Yeah, well, he's going to say that.
Yes, but do you think not only could it habitate us, could a planet hold us if case our planet becomes, like what was the series back in the 70s with Ben Green,
Buck Rogers or whatever?
No, it's
Battlestar Galactica.
Battlestar Galactica, where they're trying to find they have to find a new planet. Yeah. So, but also, do you believe that there are extraterrestrials or other life forms out there on other planets?
You ask if I believe it. I don't actually believe either way. If I was going to bet on it, I would bet strongly in favor of there being life elsewhere. Mm-hmm. I'd bet strongly in favor of there being intelligent life elsewhere. But the truth is, we don't know. And as a scientist, until you have evidence, you really have to be humble enough to say, we just simply don't know. Now, there are some things I kind of doubt. I doubt if we're going to find Klingons that speak English with a British accent.
Right.
Wow.
I doubt if that's going to happen. And I kind of doubt if we're going to find aliens that are come to Earth to suck our brains out or to steal our water or our women. I don't think those kind of things are going to happen just because they're so implausible. As a scientist, I can't rule them out, but I think it's just very unlikely. But what you can say is that the universe is so incredibly big and there's so many planets out there. And it appears that life originated on Earth so easily, so quickly, that if it happened elsewhere, then there's probably a universe full of life out there. And that includes not just life like us, but life of other forms. Maybe life that's not based upon the carbon atom, but on the silicon atom. Maybe there's life that's not even based upon molecules at all, but as I said, electromagnetic patterns in a metal. Or maybe something even more bizarre than that, things that we can't imagine at this point. I would bet that that's the way the universe is going to be. But even having said all that, my expectation is the universe is going to even still surprise us. It's going to be even more fascinating than that.
Amazing.
It's a strange lesson that we've learned in studying our solar system. Every time we go to a new planet, we're surprised. When we had the New Horizons Pluto mission, we had about 24 of the most of the world experts on Pluto that planned this mission for 20 years. And yet all of us, when we saw the images come back from Pluto, we were stunned. Who would have expected to see dried up lakes on Pluto, or glaciers that were still moving, or a surface that was young that says that Pluto is still geologically active, or that Pluto has an ocean of water underneath its surface? Who would have expected any of those things? I mean, we were all astonished. And I think that that's going to be the same experience we have whenever we go anywhere in the universe. We're going to be surprised. That's the lesson we've learned from exploring our solar system.
Well, we have about 7 minutes left, and I want to ask, when you wrote this book, I mean, really, what was the motivation to write it anyway? Because I mean, it's a great book, and you're a fascinating guy, but many scientists have the same information. Why did you want to put it on book?
I think that I was just so excited about the things that we were discovering. I just wanted to share it. I mean, this book is going to be out of date in 5 years. You have to face that. I mean, seriously, nobody's would pay a dime for it 5 years from now.
Wow.
Because it's going to be so out of date, it'll be archaic history.
That alone is fascinating. Am I right?
But that's how the world is changing.
Yeah.
And how the frontier of science is changing. But right now, at this moment, we're discovering these amazing things. We're living at a special time in human history when nothing like this has ever happened before. And all of this excitement is being lost. It's being drowned out by, of course, as you know, the political landscape in our around the world. That drowns out all these amazing things that are happening right now that people are missing. I mean, this is just incredible stuff. We're going to find life on other planets. I would bet on that. And that's a big story. That's a big deal.
Until then, it's not a big story, though, because Tony and I were talking at the break that all of the stuff you're saying is so fascinating and so interesting. Why can't we see that on the news? Why aren't people talking about this? You don't see it much, unless you dig down to try to find it. You don't hear this in the everyday thing. We're too worried about, Trump or whatever.
That is exactly why I wrote the book, because
Perfect.
I want to get it out there. I mean, that's the answer. It's you got to fight this overwhelming morass of negative information that's out there. It's not that it's unimportant. I mean, the stuff that's happening politically is certainly very, very, very important. But there are other things that are happening too that are important, and that are happening and that are important for a bigger picture view of human history, of what's going to happen to humans 50 years from now, not the next election, but
Right.
what are humans going to do 100 years from now? Are we going to move to asteroids? Are we going to move to the moon? Are we going to move to Mars?
Do you think we'll move off planet? Do you think that will happen?
Of course. I think that we will move. We will have colonies on the moon and Mars and asteroids in 100 years.
Wow.
Why asteroids?
Because on asteroids, there are far more resources than anything we could find on Earth. There's more water, there's more carbon, there's more raw materials, there's more metals
I wouldn't even thought.
that have been mined in all of human history on the surface of the Earth. And they're easy to get to. You can just hop around from one asteroid to the. I'm oversimplifying, but you can.
Yeah. Again, easy is a relative term. This guy, 7 million miles was
going
nothing.
to the moon or going to Mars or going from the moon to Mars.
Yeah.
Going from one asteroid to the other, you don't have to worry that much about their gravity. So it is easy from a space travel perspective. And the resources are just there waiting for us. Of course, it's going to be a challenge. Who owns this stuff? That's going to be a battle. We're going to have to invent new disciplines like space medicine. How do you do CPR in space? Do you know how to do that?
Do one
Again,
push and you
answer
fly
that
out.
question. Yeah,
You're
right.
like,
Wow.
I mean, most likely you've had a course of CPR, but how do you do it in space? There's not a person on this planet that knows how to do it. You might think, well, you just push someone up against the floor and give compressions, but it doesn't work that way because blood flows differently in zero G.
Oh, really?
Something as simple as CPR, we're going to have to reinvent. How about simple surgery in space? You cut someone open, well, you better be prepared for splatter. How do you do stuff like it? And then the body changes in space. So space medicine is going to have to be invented. Space law is going to have to be invented so that we know who owns what. Space manufacturing, space robotics, artificial intelligence, all these things are going to drive us into, or they're going to carry us into the solar system. And another answer to your question about why I think this is important is because I think that this is our future. What we're looking at, what we're discovering is our future homestead. I mean, it's not going to be 10 years or 50 years or 100, but a few hundred years to 1,000 years from now, what we see in our solar system, that's our backyard. Okay.
So
and then we start hopping to next stars and the next star. Now, who knows what we're going to find out there? We may find that those are already claimed, okay?
Right.
And that's a possibility as well. But we still have our own solar system to explore, and that could keep us going for millions of years, I suspect.
Well, we only have about 3 minutes left. I want to ask this: why would we? Okay, if let's say planet Earth, do you think planet Earth will be a dead planet? And even if it becomes a dead planet, why would you go to Mars because it's a pretty much dead planet anyway? So why would we want to? Can we just build it here then? Whatever the colony like we would on the moon or Mars, or is it just more for like exploratory?
We have many options going into the future. We know that the sun is going to expand and eventually consume the planets like Mercury, Venus, Earth, and Mars. But that's 2 billion years away.
Yeah.
I'm not worried
so we have
about
time.
Okay.
We're good.
So we have time to get our act together with the Earth's environment.
Mm-hmm.
We have time to build habitats on the moon, on asteroids, on Mars, in the outer solar system. We have time to hollow out asteroids and send them to nearby stars long before the Earth dies. I'm not worried about the Earth dying just yet. I'm not going to tell you what I am worried about, but I'm not worried about the Earth dying. Put it that way.
Oh, now I want to know.
Now, humanity has this tendency of inventing ways to kind of
Destroy itself.
to hurt itself, and that's what I worry about a lot. Humanity is very good at killing each other, and if we can overcome that, then we've got this future in space that we can all enjoy.
What I'm worried about is getting this book in time, because in 5 years it's worthless. Do you realize that?
Right.
Folks, go out there and get this book now because it's relevant. It's fascinating. Obviously, we'd love to have Michael back on here to talk more about this because
Anytime. I love talking about this stuff.
we love hearing it because it's really interesting to me. And I think you guys should check this book out.
Say it one more time.
I haven't even gotten to the good stuff yet.
Well,
See? It's leaving a cliffhanger.
he's learning. He's learning. That's called a tease. So that means he.
Exactly what it was.
Well, thank you so much, Mike. We so appreciate you. And please go out and pick up the book. And if you can get it on Amazon, you can go to SmithsonianBooks.com. It's called Exoplanet, Diamond World, Super Earth, Pulsar Planets, and the New Search for Life Beyond our Solar System. And we appreciate you so much. And you're going to come back, and we got it on tape, so that's the way it is. All right. Thank you, sir.
Thanks a lot,
we'll
Michael.
talk to you soon.
Did it make sense?
Oh, please. Yes.
Absolutely.
You did a great job. You did a great job.
Very good.
All right.
Okay,
Well,
thank you. Bye-bye.
all right. Take care.
Okay.
All right, guys. Well, it is time for us to say goodbye for this week on Truth Be Told. But you can check us out on iHeartRadio, iTunes. Go to our YouTube channel, Truth Be Told. Just type in anything you want. We have pretty much, I think, almost 500 episodes now. And I think pretty much for anything for anybody.
There's some food. You got a lot to chew on right now after listening to this guy, right? I mean,
Please.
that was fascinating.
It's going to be, pick up the book. Go to Amazon. Go wherever you can get it. So anyway, we got to get out of here. We've got the next show coming up. But we'll see you next time on Truth Be Told. I'm Tony Sweet.
Captain Ron.
Bye.